Imagine a world with a colossal projects shaping our landscapes. Things like intricate new urban roads weaving through cities, or maybe the super delicate restoration of a centuries-old building, even huge ports, or the operational flow of an airport.
Yeah, those massive, complex undertakings.
Exactly. Imagine if those were consistently delivered on time, under budget, and crucially, with dramatically fewer accidents. It sounds almost, well, too good to be true, right?
It really does. Especially when you think about the construction industry. I mean, it's often kind of plagued by delays, costs spiraling out of control, and sometimes, yeah, safety issues. Predictability isn't usually the first word that springs to mind.
No, it isn't. Unforeseen challenges feel almost foreseen expected, even.
Right. But what if there was a way to fundamentally, rewrite that story, to
Yeah.
bring a level of predictability, a level of excellence that maybe most people don't think is possible in that environment?
Exactly. And that's precisely what we're diving deep into today. We're talking about lean methodology, and it's surprising, sometimes counterintuitive, but really profoundly transformative impact on construction and roadworks. It started, believe it or not, in post-war Japanese car factories facing huge resource scarcity.
That's right. Toyota.
And now it's quietly but powerfully revolutionizing how we build our entire world. It's this amazing journey from an assembly line to, well, a muddy construction site.
It truly is a remarkable evolution. You take this philosophy born in a highly standardized, repetitive production environment,
Yeah.
and you try to apply it to the unique, sometimes chaotic, always variable world of construction.
Yeah.
The challenge is immense, but honestly, the results we're seeing, they really speak for themselves.
So our mission today is to unpack how this lean approach works. How does it help eliminate waste? And we'll talk a lot about waste optimized processes and create just immense value in these really unique, challenging construction settings. We'll explore its core principles, dig into some specific tools. It uses things like value stream mapping or the last planner system.
Key tools, yeah.
And then, crucially, we'll walk through real-world case studies. We want to show you how this leads to tangible benefits. We're talking efficiency, cost savings, better safety, even environmental sustainability. It's about building smarter, not just, faster or cheaper.
And for this deep dive, our source material is pretty comprehensive. It's a document that meticulously explores how lean is being applied in construction today. It's packed with insightful analysis and, importantly, concrete examples from actual projects.
So we're not just talking theory here.
No, not at all. We're looking at what's actually happening on the ground, boots on the ground, and the profound shifts it's enabling. It's quite something.
Okay, let's get into it then. When I first heard lean, like you said, my mind immediately went to manufacturing car factories. That's where it all began.
You're absolutely spot on. The lean philosophy, as we understand it today, is deeply, deeply rooted in Japan's post-World War II era. We're talking specifically about the Toyota Production System, or TPS.
Right, TPS.
Yeah. Developed by two truly visionary individuals, Taiichi Ono and Shigeo Shingo. This is back in the 1950s.
Okay.
And Japan at that time was facing just severe resource limitations. They simply couldn't compete with the sheer scale of Western mass production.
They had to be smarter.
They had to be smarter. Toyota wasn't just trying to build cars, they were trying to build them intelligently, with a core focus on eliminating every single shred of waste of time, waste of materials, waste of effort, and maximizing value for the customer, all under these extremely constrained conditions. It was really a philosophy born out of necessity.
That makes sense. Scarcity often drives the most powerful innovations, but the name lean, Toyota didn't call it that, did they? That came later.
That's right, yeah. The actual term lean or snello in Italian, which means swift or nimble, wasn't coined until the 1980s.
Oh, that much later.
Yeah, quite a bit later. Came from some groundbreaking research by a team at MIT. They were meticulously studying the differences between Western and Japanese production systems, really trying to figure out Toyota's, well, seemingly miraculous success.
What were they finding?
Their findings were documented in a hugely influential book, The Machine That Changed the World. And what they highlighted was just astounding. Toyota was producing higher quality cars with fewer defects, using significantly fewer resources, less time, less space, less human effort compared to their American and European competitors.
Wow.
This incredible efficiency, this remarkable lack of excess in pretty much every facet of their operation. That's what led the MIT team to coin the term lean.
That's a profound realization, isn't it? Doing more with less, but also doing it better. It really challenges that old industrial idea that speed or low cost automatically means, lower quality.
Exactly. Toyota proved you could have both, better quality and higher efficiency. And this paradigm shift led to the gradual adoption of what became known as lean principles across all sorts of industrial sectors globally.
So what are those core foundational concepts from TPS that became lean?
Well, the big ones are just in time, or JIT.
Heard of that one?
Yeah, it's probably the most famous. It's all about producing or acquiring only what is necessary, exactly when it is necessary, avoiding those huge stockpiles.
Oh, okay.
Then there's Jidoka. This one's a bit harder to translate, but it's often called intelligent automation or automation with a human touch.
What does that mean in practice?
In a factory, it means machines that can actually detect errors and stop production automatically. So you prevent defects from moving down the line.
Yeah.
It's about building quality in at the source, not inspecting it out later.
Okay, so how does Jidoka translate to a construction site? You don't exactly have an assembly line you can just stop.
That's a great question, and it really highlights the adaptation needed. You're right, you can't stop a whole factory. In construction, Jidoka is more about implementing systems that prevent errors from propagating downstream.
Like what?
Well, imagine maybe a smart sensor system that detects an incorrect concrete mix before the pour happens. Or perhaps a digital quality check on a prefabrication line that flags an issue with a building module before it even leaves the workshop.
Ah, I see. So catching the problem right at the source.
Exactly, before it becomes a much bigger, more expensive, and more time-consuming problem to fix later on the actual site. It's about intelligent error prevention embedded in the process.
That makes a lot more sense for construction. Okay, what other core concepts are there?
Another huge one is Kaizen. This is the idea of continuous improvement.
Right, always getting better.
Precisely.
Yeah.
But it emphasizes small, incremental changes made by everyone, every single day, not just big top-down initiatives. It's about fostering a culture where every single worker feels empowered to identify problems and suggest solutions.
That sounds quite different from traditional hierarchies.
It is, and that ties into the final, often overlooked, but absolutely vital principle, respect for people. This means genuinely valuing the skills, the knowledge, the ideas of all workers, recognizing that the person doing the work often knows best how to improve it. They're invaluable assets in that continuous improvement process.
Okay, so these principles, JIT, Jidoka, Kaizen, respect for people, they were born in highly repetitive, standardized factories. But a construction site, I mean, every project is unique, the ground conditions change, the weather's unpredictable.
A million miles away, yeah.
It seems like such a huge leap. How did Lean even make that jump from the predictable factory floor to the unpredictable construction site?
You've absolutely nailed the core paradox there. It is a significant leap, no question. Construction projects are, as you say, inherently unique, non-repetitive, subject to highly variable conditions, adapting principles that seem to thrive on standardization and control. Well, it requires immense creativity, flexibility, and really understanding the spirit of Lean, not just blindly applying the tools.
So it's not just copying.
Definitely not. But, and this is the key point, it's precisely because of construction's inherent challenges. The inefficiencies, the fragmentation, the unpredictability we talked about, that applying Lean emerged as this potentially revolutionary opportunity.
Ah, because there's so much room for improvement.
Exactly. It's about taking that fundamental philosophy, eliminate waste, maximize value, and finding ingenious ways to apply it in a completely different, much tougher context.
Yeah.
It's like, I don't know, using a surgeon's precision tools, but doing it out in the field, in the mud.
Fascinating analogy. So it's about deeply understanding the why behind Toyota's methods, not just the what, and then translating that purpose creatively.
You got it.
Okay, that brings us nicely to the 5 core principles of lean thinking. These were laid out by Womack and Jones, right? And there's supposed to be a kind of universal framework, applicable anywhere.
That's exactly it. These principles, articulated so clearly in their book, Lean Thinking, provide the conceptual foundation for transforming any process. Whether you're making cars, processing insurance claims, or, yes, building a skyscraper or paving a road, they give you a clear roadmap.
Okay, let's walk through them. Number 1, define value. What does that really mean on a messy, complex construction project?
It means you always, always, always start by identifying what the end customer, the client, the building owner, the community, truly considers valuable. And in construction, this is absolutely paramount because value isn't just about the lowest price tag.
Right, it could be many things.
Exactly. It means digging deep to understand what the client really prioritizes. Is it the long-term structural integrity and durability? Is it hitting a very aggressive timeline for a commercial property that needs to open? Is it absolute unwavering safety on site? Maybe it's hitting certain environmental sustainability targets like LED certification. Or for public works like road construction, maybe the highest value is minimizing disruption to the local community during the work.
So it varies project by project.
Absolutely. Every project has a slightly different set of value drivers from the client's perspective.
Hmm.
Lean demands you identify these explicitly first. Everything else in the process has to flow from that definition of value. If an activity doesn't contribute directly to achieving that value, well then it's either a necessary but non-value-adding step, or it's just pure waste.
That makes total sense because otherwise you could be optimizing things the customer doesn't care about or adding features nobody actually wants or needs. Okay, principle number 2, map the value stream. Once you know what value is, how do you map that out in construction? It sounds complicated.
It can be, but it's essential. Once you've defined value, the next step is to visualize all the activities involved in delivering that value. You need to map out the entire process from the very first design concept through procurement, all the site activities, information flows, material deliveries, right up to the final handover.
The whole thing, end to end.
The whole thing. And the crucial part here, the real insight, comes from distinguishing between activities that genuinely create value, the ones that directly contribute to what the customer cares about, and those that just generate waste, or what Lean calls muda.
Muda, the waste.
Yeah. This mapping process often uncovers a shocking amount of hidden inefficiency. Activities you didn't even realize were happening, or steps that were just soaking up time, money, and resources without adding any real value.
Okay, so you map the current reality, warts and all. Then, principle 3, create flow. How on earth do you get things flowing smoothly on a construction site with all its inherent complexities, subcontractors, weather delays, surprises?
This is where the hard work really begins. This principle focuses relentlessly on eliminating interruptions, waiting times, bottlenecks, and any obstacles between those value-adding activities you identified. The goal is a continuous, smooth progression of work.
Like a river, you said.
Exactly like a river. You want the work to flow without dams blocking it, without chaotic rapids, without stagnant pools where nothing happens. In construction, this means ensuring materials arrive precisely when needed, not too early, not too late, making sure the right equipment is available and functional, and ensuring different teams, plumbers, electricians, drywallers, coordinate seamlessly so one task can immediately follow another without frustrating delays or rework. It's a constant pursuit of removing friction from the system.
Okay, that leads to the 4th principle, implement the pull system. Now, this one always sounds a bit counterintuitive, even in manufacturing. Why not just push everything through the system as fast as possible? Isn't that faster?
It might seem faster in the short term for one specific task, but pushing creates a massive problem: overproduction. And overproduction is one of the biggest forms of waste, because producing things before they're needed creates excess inventory, ties up capital, requires storage space, increases handling, risks damage or obsolescence. The list goes on. The pull system flips that. It means you only produce or supply something when the next step in the process signals it needs it.
So downstream demand pulls work through the system.
Exactly. You don't build up huge piles of inventory just in case. You don't start a task until the preceding one is genuinely completed and ready for the handover. This prevents that unnecessary accumulation of materials, equipment, or even finished components like prefabricated walls. It ensures resources are used only when truly needed, minimizing all those associated costs and risks. You avoid having, say, massive stockpiles of rebar or timber sitting on site for months before they're actually required.
Right, taking up space and getting weathered. Okay, and the 5th and final principle, pursue perfection, also known as Kaizen. This loops back to that continuous improvement idea. It's not a one-time project, is it?
No, absolutely not. This is crucial. Lean isn't a program you implement and then you're done. It's a journey, not a destination. It's about adopting an ingrained approach of continuous improvement, Kaizen.
Constantly looking for ways to get better.
Constantly striving to reduce waste and increase value. Every challenge, every mistake, every delay encountered on site. It's not seen as a failure or something to hide. It's seen as a priceless opportunity to learn and get better. It's about fostering a culture where everyone, from the newest apprentice to the most senior project manager, is actively looking for ways to make small, incremental improvements that over time add up to truly significant results. It's the engine that drives sustained progress.
So at the heart of all 5 principles is identifying and eliminating that waste, that muda. You mentioned there were originally 7 types, but an 8th crucial one was added later. Let's walk through them with construction examples because understanding these seems fundamental.
Absolutely. Recognizing waste is the first step to eliminating it. Let's picture that busy urban construction site again. The site foreman walks on first thing. He sees a huge pallet of expensive custom windows delivered 3 weeks early because someone wanted to be safe. They're now sitting right in the main accessway, covered in plastic. That's excessive inventory. Material stored long before it's needed, tying up capital, taking up precious space, and risking damage.
Right. And getting in the way, which probably leads to other wastes.
You bet. Because those windows are in the way, a forklift driver has to take a long, convoluted route to move some drywall, maybe even have to move the windows temporarily. That's unnecessary transport. Moving materials more than necessary adds zero value, just cost, time, and potential for accidents.
Okay, what else?
Later, a concrete truck arrives precisely on schedule, but the crew isn't ready.
Yeah.
The formwork isn't quite finished, or the pump isn't set up. The truck driver has to sit there for 45 minutes, engine running. That's waiting. Idle time for expensive equipment. Idle time for the crew waiting for the preceding step. Burning fuel. Pure waste.
Frustrating for everyone involved, too. I can see how that cascades. What about waste related to the workers' actions?
Okay, picture an electrician who has to walk back and forth across a huge floor plate multiple times to get different tools or components from a disorganized gang box. That's unnecessary motion. Any movement by workers that doesn't directly add value to installing the electrical system. Or maybe a plumber uses an overly complex, time-consuming method to connect a standard fitting because the standard procedure wasn't clearly communicated or available. That's inappropriate processing, using the wrong tool, the wrong method, or doing more work than necessary for the required outcome.
Making things harder than they need to be. And then the big one, defects.
The one everyone dreads. Mid-afternoon, the supervisor discovers a section of drywall was installed incorrectly and needs to be torn out and redone. That's a defect. It means rework, wasted materials, wasted labor, and schedule delays. It's incredibly costly.
And overproduction. How does that show up in construction? It's not like making too many cars.
It's subtler, but it's there. Maybe the design team specified overly complex structural steel connections because they weren't fully sure about the loads, leading to more fabrication and installation time than strictly necessary. Or perhaps crews complete all the framing on all floors before any other trade starts, creating a huge batch of completed work that sits idle. That's overproduction, doing more work than is immediately needed by the next step in the process. Or creating something more complex or robust than required by the actual value definition.
Okay, that clarifies it. And then the eighth waste, the one added later, often called the most important.
Yes, unused talent, or sometimes called underutilized human potential. This is about failing to tap into the skills, knowledge, experience, and creativity of the people doing the work.
How does that manifest?
Imagine that experienced carpenter who knows a much faster, safer way to install trim, but nobody ever asks him. Or the young engineer who has a great idea for using a digital tool to track progress, but the company culture discourages suggestions from junior staff. That's a colossal waste of intellectual capital, innovation potential, and problem-solving capability right there within the team. It's not leveraging your most valuable asset, your people.
Those examples make it crystal clear. While the terms come from manufacturing, these wastes are absolutely rampant in construction. And this really leads us to why construction is so different. You touched on the challenges, but let's really compare it directly to a factory setting.
Yeah, understanding these differences is critical to understanding why lean needs such careful adaptation. Let's break it down. First, the work environment. Industrial factory. Typically controlled, indoors, constant temperature, good lighting.
Right.
Construction site. Variable, mostly outdoors, subject to rain, wind, extreme heat, or cold.
Yeah.
That variability alone is a massive factor.
Totally different realities. What about the work itself?
Repetitiveness. High in industry. You're making the same widget thousands, maybe millions of times using standardized processes. Construction. Repetitiveness is low. As we said, every project is fundamentally unique. You can standardize tasks, but the overall project context is always different.
Okay, and how things move. Product versus people.
In a factory, the product moves down an assembly line. Workers are largely stationary. Construction. It's the opposite. The product, the building, the road, the bridge is stationary. The workers and equipment move around it. This completely changes the logistics of workflow, material delivery, everything.
That's a fundamental difference. And the cycle duration. Manufacturing is fast.
Very fast. Industrial cycles are often measured in minutes or hours per unit. Construction cycles, even for individual major tasks like pouring a floor or erecting a steel frame, are long. We're talking days, weeks, sometimes months. This means feedback loops are much slower, and planning horizons have to be different.
What about the way teams are organized?
Industrial organizations tend to be hierarchical and relatively stable over long periods. Construction is inherently temporary and project-based. Teams assemble for a specific project, designers, contractors, subcontractors work together, and then disperse. This makes building long-term organizational learning and a consistent culture much more challenging across different projects.
And that supply chain fragmentation you mentioned earlier.
Nightmare is a strong word, but it's complex. Industrial supply chains are often highly integrated, built on long-term collaborative relationships. Construction supply chains, much more fragmented. Relationships are often temporary, project-specific, sometimes adversarial, driven primarily by bid price. This leads to less trust, poorer communication, and makes coordinating that smooth flow much harder.
All these differences, environment, uniqueness, mobility, duration, organization, supply chain, they must add up to way higher variability in construction, right?
Absolutely. Industrial processes are designed and controlled to minimize variability. Construction is inherently high in variability due to all those factors, plus many unpredictable external ones like weather or discovering unexpected ground conditions.
And that must totally change how you plan.
It has huge planning implications. Industrial processes allow for detailed, highly reliable, long-range planning. Construction planning needs to embrace flexibility and adaptation. That's why tools like the Last Planner System, LPS, are so crucial. LPS emphasizes collaborative planning, making reliable short-term commitments, and progressively detailing the plan only as you get closer to the actual work. It's about adapting to reality, not forcing reality to fit a flawed long-range plan.
So despite all these stark differences and massive challenges, the call for lean construction isn't just wishful thinking. You're saying the core principles eliminate waste, define value, create flow, pursue perfection, they absolutely still apply.
They remain incredibly valid and powerful. The core philosophy holds. The challenge, and frankly the exciting opportunity, is to creatively adapt the lean tools and techniques to the specific messy realities of the construction sector. It's not about force-fitting factory solutions. It's about developing bespoke approaches. Yeah. That's what defines true lean construction.
Okay, let's get into those adapted tools now. How do they work in practice on site? Let's start with value stream mapping, VSM. How does this tool actually uncover those hidden inefficiencies in construction, the things that contribute to that shocking 70% non-productive time figure?
VSM is a fantastic diagnostic tool. When you adapt it right for construction, it basically helps you visualize the hidden factory of inefficiency that exists on almost every project.
Yeah.
Its purpose is simple but profound. Visualize the entire process end to end, from the very first client idea or need, through design, approvals, procurement, all the on-site work, inspections, handover, everything.
Seeing the whole picture.
Exactly. And the key is to rigorously identify which steps actually create value from the customer's perspective, and which steps are, well, just waste or necessary non-value-adding activities. You might think you know your process inside out, but VSM often reveals some really startling truths about where time and money are actually going.
So how do you begin? How do you define value clearly enough for a construction VSM? We said it's subjective.
You have to make it objective through discussion with the client and project team. It's always customer-centric. What does this specific client value most on this specific project? As we discussed, it could be speed, cost certainty, quality of finish, safety, minimal disruption, sustainability. You need to define those key value drivers up front. Because if an activity doesn't directly contribute to one of those, you have to ask, why are we doing it? Is it truly necessary, or is it waste? It forces you to challenge every single step.
Okay, and what's the actual process of doing the VSM in construction? Mapping something so complex sounds daunting.
It usually starts by creating a current state map. This is where cross-functional team designers, contractors, key subs, maybe even the client gets together and meticulously documents every single phase of the process as it actually happens today. Not how it's supposed to happen, but the reality.
Memo and all.
Exactly. You track the time spent on each activity, crucially the waiting times between activities, how information flows or doesn't flow, material movements, decision points, approvals. This exercise is often incredibly eye-opening. It's not uncommon, as the research suggests, for this mapping to reveal that less than 30% of the total project lead time is spent on actual value-added construction work.
Less than 30%, that's staggering. It really visualizes that 70% waste figure we talked about. It's like finding out your car engine is only firing properly 30% of the time. So what do you do once you have this often quite painful current state map?
Once you have that clear picture of the current reality, the team then collaborates to design a future state map. This is where you apply lean principles systematically. How can we eliminate the non-value-added activities entirely? How can we drastically reduce the necessary but non-value-adding ones? How can we optimize the value-adding steps to make them flow better?
What kind of practical strategies emerge from this future state mapping in construction?
It can lead to really concrete changes. For instance, significantly increasing the prefabrication of components like bathroom pods or facade panels off-site in a controlled environment. This reduces on-site labor, improves quality, and cuts down on weather delays and site congestion.
Makes sense.
Or maybe reordering work sequences to minimize those waiting times between different trades, ensuring the site is truly ready for the next crew when they arrive. Implementing better digital communication systems so design clarifications or approvals happen in hours, not days or weeks, eliminating huge chunks of waiting time.
And does this VSM work actually translate into real project improvements? What are the tangible benefits?
Oh, absolutely. The documented benefits are significant. We've seen case studies where projects achieve reductions in overall delivery times of up to 30% just by rigorously applying VSM, identifying the biggest bottlenecks and wastes, and then systematically addressing them. It's about making that hidden factory of inefficiency visible and then taking it apart piece by piece.
Incredible impact just from mapping and rethinking the flow. Okay, next tool. Just in time. JIT for material management. Sounds great in theory, the right materials, right place, right time, but on a sprawling, unpredictable construction site, that sounds like a massive logistical challenge.
It is challenging, no doubt.
Yeah.
But the core idea is exactly as you said. Receiving materials precisely when they are needed for installation in the exact quantities required and, importantly, at the right quality level. It's a fundamental shift away from the traditional just-in-case stockpiling approach towards a synchronized flow.
Why is that traditional stockpiling, that safety stock, such a problem? It feels safer, doesn't it, having stuff on hand?
It feels safer, but it actually creates a whole cascade of problems and wastes. First, it occupies valuable site space, and space on construction sites, especially urban ones, is often incredibly tight and expensive. Second, it ties up huge amounts of capital and materials that are just sitting there not earning anything.
Dead money.
Dead money. Third, there's a significant risk of material damage or deterioration when things are stored for long periods, exposed to weather, moisture, or just getting knocked around on site. Fourth, it increases unnecessary movements and the associated risks, as materials inevitably have to be shifted multiple times to get to what's behind them or to make space. Fifth, it actually makes it harder to find the right materials quickly when you need them, leading to wasted search time. And finally, it increases the risk of obsolescence if designs change or specifications get updated before the stockpile material is used. So that feeling of safety is often an illusion masking hidden costs and inefficiencies.
Okay, you've convinced me stockpiling is bad. So how do you actually implement JIT in the messy reality of construction? What does it take to make it work, especially with unpredictable factors like weather or supplier hiccups?
It requires several key things. First, incredibly accurate short-term planning, often linked to that last planner system we'll talk about. You need to know exactly what's needed, where and when in the near future. Second, and this is crucial, it requires strong, trust-based collaboration with suppliers. You have to move away from purely transactional lowest bid relationships towards genuine partnerships built on reliability and open communication.
So fewer but better supplier relationships.
Often, yes. It might mean consolidating suppliers to build those deeper relationships. Contracts need to be structured differently, too, maybe specifying frequent, smaller batch deliveries timed precisely with the work schedule, rather than huge bulk drops. And third, you absolutely need advanced planning and communication systems, often construction-specific ERP software or cloud-based platforms, to help coordinate and synchronize those material arrivals with the actual workflow in near real time.
What about those tricky situations? Really huge sites where the work zone is miles from the gate, or super tight urban sites with almost zero storage space?
That's where smart adaptation comes in. You might not achieve pure factory-style JIT in every single case. For large sites, you might use designated, highly organized, controlled buffers or staging areas near the workface. Materials arrive just in time to the buffer and are then distributed just in time to the exact point of installation, minimizing travel distance and double handling on the vast site.
So a mini JIT within the site?
Kind of, yeah. For very congested urban sites, you might rely heavily on meticulously planned off-site consolidation centers, or require suppliers to use smaller delivery vehicles that can navigate tight streets, making time deliveries perhaps even during off-peak hours or overnight. It's about finding creative solutions that maintain the principles of JIT, minimize inventory, maximize flow within the specific site constraints. It requires calculated planning, not just hoping for the best.
And you have a great case study for this, that urban roadwork project on Valle Montanaro in Milan back in 2019. That sounds like JIT hard mode.
It really does.
Mm.
This project is a fantastic example of JIT pushed to its limits in an incredibly challenging urban environment. They were doing a complete reconstruction of a major arterial road utilities, sidewalks, road surface, everything. The challenge was immense. Extremely limited space to work, the need to keep heavy traffic flowing continuously on adjacent lanes, and immense pressure to minimize disruption to residents and businesses lining the street. Traditional planning estimated it would take 18 disruptive months.
18 months of chaos on a major Milan road. Okay, how did they use JIT to tackle that without gridlocking the city?
Their JIT solution was really clever and very disciplined. Instead of closing huge sections for long periods, they broke the work down into small, sequential 50-meter lots,
Oh.
almost like creating a moving production line right there on the street.
Wow.
Deliveries were precisely synchronized with the workflow in each lot. They often used prepackaged kits of materials prepared off-site specifically for the next day's tasks in that 50-meter zone. These kits were delivered overnight, directly to the point of use, to avoid daytime traffic disruption. And crucially, excavated materials were immediately loaded onto trucks and removed from the site. No piles of spoil sitting around blocking things up. Even temporary drop-off points had materials cleared within hours.
That sounds like military precision. What were the results? Did it actually work?
The results were outstanding. This rigorous JIT implementation, combined with other lean practices like LPS, contributed to a 30% reduction in the overall project duration. They finished in just 12 months instead of the planned 18.
6 months faster.
6 months faster. And specifically related to JIT, they documented up to a 50% reduction in material inventory held on that constrained site, and a huge decrease in unnecessary material movements, meaning fewer delivery trucks clogging the streets, less noise, less pollution, less disruption. It brilliantly demonstrated that even in the most congested, complex urban settings, JIT principles can deliver massive benefits.
That's truly impressive. Cutting a major urban project by a third is a huge win for everyone, especially the public just trying to get around. So, beyond materials, Lean also focuses intensely on optimizing the workflows themselves and reducing those dreaded dead times. That cascading problem of delays, everyone who's worked on a project knows that pain.
Oh yes, it's a critical issue that just plagues traditional projects. An inefficiency or a delay in one early activity, say the foundation pour is late, inevitably ripples through the entire schedule. It causes waiting time for subsequent crews, increases costs, compresses schedules later on, leads to rushing, mistakes, and often just creates a chaotic, stressful work environment as everyone scrambles to catch up. Lean tackles this head on.
How? What are the specific Lean solutions to stop that domino effect before it starts?
Well, first, they start with rigorous workflow analysis. This means going beyond a simple Gantt chart. It involves detailed mapping of all the project activities, understanding their intricate interdependencies, identifying the true critical paths, and pinpointing potential bottlenecks. They often integrate Gantt charts with more visual tools like location-based management or line of balance schedules, which help visualize the flow of work across different physical areas of the site over time. This really highlights where crews might clash, or where work might stall.
So you see the potential traffic jams before they happen. And once you've mapped it, you need to balance the workload, right? Not just optimize one trade in isolation.
Exactly. Resource balancing is key. Traditional methods often focus on optimizing each individual activity. Lean aims to balance the entire workflow, ensuring a smooth, continuous flow through the whole project. This might mean reallocating crews, adjusting team sizes, or even modifying the sequence of activities slightly to prevent overloads in one area while another sits idle. It's about optimizing the system, not just the parts.
What about breaking the work down into smaller chunks? Does that help flow?
Definitely. That's the idea behind reducing batch size. Instead of, say, completing all the structural steel for an entire building before any floor slabs are poured, a huge batch, Lean encourages breaking work down into smaller lots. For instance, maybe completing the steel slab and exterior walls for 1 or 2 floors completely, allowing interior trades to start much earlier in those areas while the structure progresses above. This gets work flowing through the system faster, provides quicker feedback, reduces the amount of work in progress sitting idle, and shortens the overall project duration.
Even on unique projects, can you find ways to standardize parts of the process?
Yes, absolutely. That's process standardization. Even within a unique building project, many specific activities are repetitive. things like installing standard door frames, connecting specific pipe fittings, performing routine quality checks, or applying a particular type of waterproofing. Defining clear, standardized procedures for these common tasks reduces variability, minimizes errors, improves efficiency, and makes outcomes more predictable. This frees up mental energy for the team to focus on the truly unique, complex aspects of the project.
And then you need to keep a constant eye on things, right? Monitor progress in real time.
You got it. Continuous monitoring is vital. This involves using real-time data where possible, but more importantly, having frequent, short, focused communication loops. Daily stand-up meetings or huddles are a cornerstone. Teams meet briefly every morning to discuss what was achieved yesterday, what the plan is for today, and crucially, identify any constraints or roadblocks immediately. This allows for rapid problem-solving and course correction, preventing small issues from snowballing into major delays.
Are there any sort of powerful overarching techniques that bring these solutions together, beyond just the individual parts?
Yes, there are. One very powerful technique, adapted cleverly from manufacturing, is takt time planning. Takt time, in essence, is the heartbeat of the production system, the rate at which you need to complete work to meet the overall project deadline or customer demand.
Setting a rhythm.
Precisely. In construction, it means figuring out the optimal pace or duration for completing repetitive work within a specific zone or floor, say how many days per apartment unit or per floor level. It helps create a predictable rhythm and ensures all trades are working at a balanced pace. When applied effectively to large, relatively repetitive projects like hospitals, apartment buildings, or commercial towers, takt time planning has been shown to reduce overall construction times by as much as 30%. It's about building to a consistent rhythm, not just a series of chaotic deadlines.
30% faster just by setting a rhythm. That's huge. And there's another concept, one-piece flow construction. How does that apply to something as massive and complex as a building? It sounds almost impossible.
It's definitely a more advanced, almost philosophical concept, inspired by the ideal of a single-piece flow in manufacturing, where work moves smoothly from one step to the next without any waiting or badges. In construction, it means rethinking the project, not as a collection of separate, disconnected activities performed by different silos, but as a continuous flow of value creation.
How would that look?
It involves designing the entire project from design release through procurement, fabrication, and site installation to move as smoothly as possible, almost like a single unit, from start to finish. Minimizing work in progress between stages, ensuring seamless handoffs, it requires a radical rethinking of traditional planning, scheduling, and site organization. But the potential payoff, in terms of dramatically improved delivery times and resource utilization, is enormous because you're always focused laser-like on the very next value-adding step, keeping everything moving.
It sounds like a fundamental goal is making everything progress, problems, plans completely visible. Which brings us to visual management. How does that work on a construction site, which can often feel like a black box?
Visual management is an absolute pillar of Lean. It's based on a really simple but profound principle. Making information, processes, performance, and problems visible allows for immediate understanding, faster communication, and timely intervention. On a complex, often dispersed construction site where miscommunication is easy, this is invaluable. It's about making the invisible visible to everyone involved.
What are the concrete benefits of making everything so transparent on site?
The benefits are huge and touch almost everything. It enables immediate and transparent communication. Everyone can see the status at a glance, reducing misunderstandings. It leads to rapid identification of problems and delays. A red marker on a board is instantly noticeable. It fosters increased team accountability because progress, or lack thereof, is public and shared. It directly reduces errors because standards and expectations are visually clear. It facilitates quicker decision-making because the relevant information is readily available. And fundamentally, it promotes continuous improvement because problems are exposed early, making them easier to discuss and solve collaboratively rather than being hidden or ignored.
So what kind of practical tools do they actually use on site for this? Is it just whiteboards and charts?
Whiteboards are definitely part of it, but it goes much further. Common tools include planning boards. These are often large physical boards, maybe using color-coded sticky notes or cards, showing daily or weekly schedules, task assignments, and progress status, clearly marked as to do, in progress, done, or block delayed. They become the focal point for daily coordination meetings. Okay. Then you have site maps. Visual layouts of the entire work area, often using color codes or symbols to clearly indicate which activities are happening where materials are stored, access routes, and crucially, highlighting safety hazards or exclusion zones. These are especially useful on large, complex sites to orient people and manage logistics safely.
And those and-on boards you mentioned, like in the Toyota factories.
Exactly,
Yeah.
adapted for construction.
Right.
And on boards can be digital screens or even simple physical light systems like red, yellow, green lights placed in key work areas. They show the real-time status of critical activities or equipment. If there's a problem, say a concrete pump breaks down or a critical material is running low, a signal, like a red light, immediately alerts supervisors and support teams, enabling rapid response. And Kanban cards, used visually, can manage the flow of materials or trigger work. For example, when a pallet of bricks is used up, the empty pallet, or its card, signals the need for replenishment, maintaining that pull system visually.
Is there a central place where all this visual information comes together? A sort of mission control?
Yes, often there is. It's called the Obeya room, which translates from Japanese as big room or war room.
Mm.
It's a dedicated physical space, usually near the site office, where all the key project information, master schedule, phase plans, look-ahead plans, VSM maps, KPI charts, problem logs, risk registers, safety stats, is displayed visually on the walls. It serves as the central hub for coordination meetings, collaborative problem-solving sessions, and strategic decision-making, ensuring everyone is literally on the same page.
It sounds like technology must be playing a bigger role now, too, moving beyond just physical boards and paper.
Oh, absolutely. Digital tools are significantly enhancing visual management. Tablets and smartphones allow teams to access plans, update progress, report issues, and view dashboards directly from the field in real time. Interactive screens in the Obeya room make collaboration more dynamic. And BIM 4D, which adds the time dimension schedule to the 3D building information model, allows teams to visually simulate the entire construction sequence. You can literally watch the building go up digitally, identifying potential clashes, sequence issues, or safety hazards before they happen on site. It's like having a crystal ball for your project's flow.
That's incredibly powerful. Okay, let's talk about perhaps one of the most celebrated and foundational lean tools specifically adapted for construction, the Last Planner System, or LPS. What makes this so innovative, and why is it considered so fundamental to making lean work on site?
The Last Planner System, developed by Glenn Ballard and Greg Howell back in the 1990s, is truly innovative because it fundamentally flips traditional construction planning on its head. Instead of top-down command and control planning, it emphasizes collaboration, reliable promising, making commitments you can actually keep, and progressive detailing of the plan. It's focused on making planning reliable and execution predictable, not just creating a fancy-looking schedule that falls apart in week one.
And the name Last Planner refers to people actually doing the work, right? The foreman, the crew leads, giving them a voice.
Exactly. The last planner is the person or group closest to the actual execution of the work. The foreman, the site supervisor, the subcontractor's crew lead. Traditional planning often ignores their detailed, practical knowledge about how long things really take, what constraints exist, and what's actually feasible on the ground tomorrow. LPS brings their expertise, insights, and crucially, their commitment right to the forefront of the planning process.
So how does LPS actually work? What are these 5 interconnected phases I've heard about that make it a system, not just a meeting?
It's a cascading planning process, moving from the big picture down to the daily details, with constant feedback loops. It works like this. 1. Master schedule. This is the high-level project plan, outlining major phases, milestones, and overall durations. It sets the strategic direction. Think of it as the roadmap. 2. Phase planning. Here, key stakeholders, designers, contractor, major subs, collaboratively pull plan each major phase of the project, like foundations, structure, envelope, MEP, rough-in. They work backwards from milestones to define the optimal sequence and handover criteria. 3. Look-ahead planning. This is a rolling, more detailed plan, typically looking 3 to 6 weeks into the future. Teams collaboratively identify upcoming tasks and, crucially, proactively identify and remove any constraints that could prevent those tasks from starting on time. For example, missing information, materials not ordered, prerequisite work not done, equipment unavailable. This is about making work ready. 4. Weekly work plan. This is the most detailed level, focusing on the upcoming week. Only tasks that have had their constraints removed, i.e. they can be done, are included. The last planners make explicit public commitments about which tasks will be completed. This plan forms the basis for daily coordination. 5. Learning and improvement. This is the critical feedback loop. Every day or week, the team reviews performance against the weekly plan. They don't just note what wasn't done, they ask why. They perform root cause analysis on missed commitments and implement corrective actions to prevent recurrence. They track percent plan complete, PPC, to measure planning reliability.
So it's a cycle. Plan collaboratively, Remove roadblocks, commit reliably, execute, and then learn from what happened. What's this should, can, will concept within LPS? It sounds almost philosophical.
It's a really powerful mental framework within LPS. It helps distinguish between should, what the master schedule or phase plan says should be done this week, the ideal, can. What can realistically be done because all constraints, information, materials, preceding work, etc., have been removed, the feasible. Will, what the last planners actually commit to getting done this week based on what can be done, the reliable promise, will. The goal of LPS is to systematically increase the overlap between can and will, making the weekly plan highly reliable. It shifts the focus from wishful thinking, should, to executable reality, will.
And the key metric is that PPC you mentioned, percent plan complete. How does that help?
Yes, percent plan complete PPC is the primary KPI for LPS. It simply measures the percentage of tasks committed to in the weekly work plan that were actually completed by the end of the week. It's not a measure of overall project progress, but a crucial measure of the reliability of the planning and workflow system. If your PPC is consistently high, say 80% or more, it means your workflow is stable and predictable, which minimizes waste, reduces stress, and ultimately leads to better overall project outcomes.
And what kind of results have companies seen from implementing LPS properly?
The documented results are consistently impressive. Studies and practice show LPS delivering significant improvements, often up to a 30% increase in on-site productivity, substantial reductions in project durations, and measurable improvements in safety and quality. Perhaps just as importantly, it fosters a much stronger culture of collaboration, trust, and shared responsibility among everyone on the project team, because they're all involved in creating and committing to the plan.
We have a fantastic case study that really highlights this in a challenging context. The restoration of the Palazzo Contarini in Venice, finished in 2020, restoring a historic building in Venice. That sounds like the ultimate test for any planning system.
It was an exceptionally complex project, yes. A true crucible for lean principles and LPS.
Yeah.
You're talking about a fragile 16th century building in the heart of Venice. The challenges were immense. Delicate existing structures, access only by boat through canals, the absolute need to preserve priceless frescoes and architectural details, and the inherent uncertainty of restoration work where you're constantly discovering unexpected conditions behind walls or under floors. The initial budget was 12 million euros with a 36-month timeline.
So how did they apply lean and specifically LPS in that environment where surprises must have been almost daily?
The restoration firm fully embraced lean, and LPS was absolutely critical, especially for that short-term adaptive planning. The look-ahead planning and weekly work planning cycles allowed the team to rapidly adjust to the unforeseen discoveries, hidden structural issues, archaeological finds that inevitably emerged. They could pivot quickly based on reality, rather than being paralyzed by a rigid, outdated master plan.
So LPS gave them the flexibility they needed. Did they track their PPC?
They did, very diligently. It started, as you might expect on such a complex project, around 40%, meaning less than half their weekly plans were being achieved initially. But as the team got better at identifying constraints and making reliable promises using the LPS process, their PPC steadily improved, reaching over 80% in the later stages. That demonstrates a huge increase in planning predictability and workflow stability, even amidst constant uncertainty.
That's remarkable, improving predictability when the work itself is inherently unpredictable. What other key lean actions did they take?
They invested heavily upfront in extremely accurate preliminary investigations. Using things like 3D laser scanning and non-destructive testing, they gained a much deeper understanding of the building's actual condition before major work began, significantly reducing the number of nasty surprises later. They also created a fully integrated, co-located project team. Designers, specialist restorers, archaeologists, engineers, even the owner's representatives all work together in the same physical space on site.
That obeyer room concept again, essentially.
Exactly. This eliminated the huge delays often associated with waiting for decisions or information when dealing with complex historic fabric. Problems could be identified, discussed, and resolved collaboratively, often within hours. They also utilized custom prefabrication cleverly. Based on the precise 3D surveys, they prefabricated complex elements like entire bathroom modules off-site, then transported them by boat and quickly installed them, minimizing disruption to the fragile building. And they carefully planned and optimized the use of their highly specialized, often expensive artisans, ensuring their valuable time was used efficiently without interruption.
And the outcome? After all that, facing all those challenges, what was the final result for Palazzo Contarini?
It was truly remarkable. Despite the high uncertainty, the stringent preservation requirements, and the logistical nightmares of Venice, The project was completed in just 30 months,
6 months ahead of schedule.
6 months ahead of the original 36-month plan. And the final cost came in at 9 million euros,
Down from 12 million.
down from the initial 12 million euro budget. That's a 25% saving against the initial budget. It's an incredible testament to how framed principles and tools like LPS can deliver significant, measurable value, faster delivery, lower cost, high quality, even in the most challenging, unique, and seemingly non-standardized construction environments. Historic preservation doesn't have to be inefficient.
That's an absolutely stunning success story. It really drives home that lean is about so much more than just efficiency and cost cutting. It seems to have this broader, sometimes unexpected, positive impact. Let's talk about one of those surprising synergies. Safety. My first instinct might be, well, if you're pushing for speed and efficiency, doesn't safety sometimes get compromised? But the data seems to say the complete opposite.
That's a very common, understandable misconception. But the evidence, when you look at companies seriously implementing lean, is overwhelmingly clear. Lean significantly improves safety performance. It might seem counterintuitive, but the data is really compelling.
What does the data show?
Well, for instance, one major study looked at 23 large European infrastructure projects. It found that the sites with high levels of lean implementation had 55% lower injury rates compared to sites using traditional management approaches. 55%. Other studies have shown things like a 72% reduction in near misses, those critical incidents that could have caused harm but luckily didn't, and an 83% increase in proactive hazard reporting by workers.
Wow, those are not small numbers. A 55% lower injury rate is massive. So how does lean actually achieve this? What are the direct mechanisms at play? It can't just be a lucky coincidence.
No, it's definitely not luck. There are several direct ways lean principles inherently create safer work environments. Firstly, consider 5S. That's the lean practice focused on workplace organization. Sort, set in order, shine, standardize, sustain. A site that applies 5S principles is cleaner, less cluttered, tools are stored properly, walkways are clear. This directly reduces trip hazards, falling object risks, and creates inherently safer, clearly defined work zones.
So orderliness equals safety. Makes sense.
It really does. Secondly, lean focuses on reducing variability. By standardizing work procedures where possible, you reduce the need for improvisation and ad hoc workarounds, which are often where unsafe behaviors creep in. When workers follow clear, agreed-upon, safe standard procedures, errors and unexpected situations decrease.
So a more predictable process is a safer process.
Exactly. Thirdly, visual management, which we talked about. Clear signage, color-coded hazard warnings, visual status boards, safety performance dashboards. All these make potential dangers and safety procedures highly visible and easily understandable, allowing for proactive hazard identification and prevention. You see the risk before it bites you. Fourthly, collaborative planning, especially using the last planner system. LPS improves coordination and communication between different trades working in the same area, drastically reducing the risk of dangerous interferences like one crew working above another without proper precautions. Safety considerations are explicitly discussed and integrated into the weekly planning meetings, making safety a planned outcome, not just an afterthought or a separate checklist.
And that Kaizen principle, continuous improvement, does that play a role in safety too, empowering workers?
Absolutely. Kaizen fosters a culture where workers feel empowered and encouraged to identify safety issues, report near misses without fear of blame, and actively participate in developing safer work methods. It shifts safety from being solely management's responsibility to being everyone's responsibility. And perhaps most fundamentally, lean reframes safety as value. It's not viewed as a compliance burden or an extra cost that slows things down. Instead, safety is seen as an essential component of the value delivered by the project. Work that compromises worker safety is, by definition, wasteful and non-value-adding.
That's a powerful reframing. Unsafe work is waste. Are there specific proactive safety approaches that fit well within a lean framework?
Yes, definitely. Lean encourages moving beyond reactive safety measures towards proactive ones. Things like safety in design, specifically, where potential hazards are identified and engineered out during the design phase itself, eliminating the risk at the source. Also, collaborative job safety analysis, JSA, where the crews actually doing the work get together before starting a task to identify potential hazards and agree on the safest way to proceed. And safety Gemba walks, where managers and safety professionals regularly go to the actual work site, Gemba, specifically to observe work being done, talk to workers about safety concerns, and identify opportunities for improvement collaboratively, not just to enforce rules.
Let's look at a case study that really exemplifies this safety synergy, the Port of Genoa container terminal expansion in 2021. That sounds like a high-risk environment to begin with.
Extremely high risk. The challenge there was enormous. They were building a new 500-meter quay, installing massive new container cranes, reclaiming land, all while the existing, extremely busy container terminal had to remain fully operational 24/7. You had complex marine logistics, heavy lifts, underwater diving operations, constant ship and truck traffic, and the absolute imperative to avoid disrupting port operations. Safety risks were everywhere.
So how did they integrate lean thinking with such an intense focus on safety in that dynamic, dangerous environment?
They made safety an integral part of every lean process, right from the very beginning. It wasn't a separate program, it was woven into the fabric of how they planned and executed the work. This included rigorous safety and design up front. They implemented pervasive visual safety management, using things like large, risk-coded site maps updated daily and real-time safety performance indicators displayed prominently. The last planner system explicitly integrated risk analysis into the weekly planning sessions, discussing potential clashes between different operations and ensuring mitigation measures were part of the plan. And they held daily huddles at the start of every shift, where crews discussed not just the production tasks for the day, but also the specific safety hazards they might encounter and the controls needed. Safety was the first topic every day.
And I understand they use some innovative technology as well to bolster safety.
Yes, they did something quite cutting edge. They deployed IoT sensors on heavy equipment and also integrated into workers' personal protective equipment, PPE, like helmets or vests. These sensors could trigger real-time alerts, for example, if a worker inadvertently entered a designated hazardous zone or got too close to operating machinery. This allowed for immediate warnings and interventions, preventing potential collisions or accidents before they happened. It was proactive, technology-enabled risk mitigation.
That's really smart. And the results, did this integrated lean and safety approach pay off in Genoa?
The results were truly outstanding, especially given the high-risk nature of the work. Over the entire project duration, spanning over 1.2 million working hours, they achieved zero serious injuries or incidents.
Zero. That's incredible.
Zero serious incidents. They also documented an 85% reduction in overall recordable incidents compared to industry benchmarks for similar port construction projects. They saw a 67% increase in near-miss reporting, which sounds bad, but is actually a positive indicator of a strong safety culture where people feel comfortable reporting potential problems.
Yeah.
And financially, they achieved a 24% reduction in their insurance premium cost due to their vastly improved risk profile. And here's the kicker. Alongside these stellar safety results, their overall project productivity improved by 20% compared to the baseline plan.
Wow, so it really proves the point. Safety and efficiency aren't trade-offs. When you do lean well, they go hand in hand.
Absolutely. The Genoa port case is a powerful demonstration that integrating safety deeply within a lean operating system makes projects not only much safer, but also more productive and predictable. They are complementary goals.
Okay, that connection is clear. Now let's pivot slightly to another major impact area, environmental sustainability. How does lean's obsession with eliminating waste naturally lead to greener construction practices, especially given construction's massive environmental footprint?
It's a really natural, almost inherent alignment. Lean's fundamental focus is on eliminating waste in all its forms. When you systematically reduce wasted materials, wasted energy, wasted transportation, wasted effort, you automatically reduce the project's environmental impact. It just makes sense.
And that impact is huge, right? Construction is a major global player in resource consumption and emissions.
It's massive. The statistics are pretty sobering. Globally, the construction sector is responsible for roughly 40% of total energy consumption, around 30% of greenhouse gas emissions, a staggering 40% of raw material usage, and about 30% of all waste generated. These are enormous figures. Lean offers tangible, practical ways to significantly chip away at these impacts.
So how specifically does lean contribute on the ground? What are the mechanisms for reducing that environmental footprint?
Well, firstly and most obviously, through material waste reduction. Lean techniques like designing for material efficiency, using modular construction, optimizing cutting patterns for materials like drywall or steel, and promoting precision prefabrication in controlled factory environments. These can collectively reduce the physical construction waste sent to landfill by up to 30%. Less waste means less resource depletion and less landfill burden.
Okay, materials are a big one. What about transport?
Logistics optimization is key. Implementing just-in-time principles and optimizing supply chains significantly reduces unnecessary transportation of materials to and from the site. Fewer truck journeys mean lower fuel consumption and reduced CO2 emissions. In dense urban areas, studies have shown this can lead to up to 40% less construction-related traffic, which also reduces congestion, noise pollution, and improves local air quality.
That's a big win for cities. What about energy and water use on the site itself during construction?
Lean addresses that too through energy efficiency. By analyzing site processes, lean thinking helps identify and eliminate energy waste. This could involve things like implementing automatic shutdown procedures for idle equipment, using energy-efficient site lighting, or optimizing the use of generators. These measures can cut on-site energy consumption by up to 25%. Similarly, for water management, lean principles can be applied to reduce water usage through techniques like rainwater harvesting for non-potable uses, installing flow control devices, and optimizing processes like concrete curing or dust suppression.
Is there a way to embed sustainability thinking even earlier, like in the design phase, using lean ideas?
Yes, definitely. A concept called target value design, TVD, which is closely linked to lean, extends the definition of value to explicitly include environmental sustainability goals alongside cost and performance targets right from the very beginning of the design process. It guides the entire project team, architects, engineers, contractors, to collaboratively find solutions that optimize cost, functionality, and ecological impact simultaneously.
And technology helps here too, I imagine. BIM.
Absolutely. Digital tools like BIM are powerful enablers. They allow teams to model and simulate different design options, predict the building's energy performance, optimize material usage, and even plan construction logistics to minimize environmental impact before construction even starts.
How do companies track this? Is it just good intentions, or do they measure their green performance?
Consistent with Lean's data-driven approach, leading companies are increasingly using real-time environmental KPIs. They track metrics like on-site energy consumption per square meter built, kilograms of CO2 emitted per project phase, percentage of waste diverted from landfill, and water usage. Monitoring these KPIs allows for timely interventions if targets aren't being met. Furthermore, implementing lean practices often makes it significantly easier for projects to achieve formal environmental certifications like EED, Leadership in Energy and Environmental Design, BREE-BRIM, or Italy's ITACA protocol. These certifications not only validate environmental performance, but also enhance the company's reputation and competitiveness.
So lean really does help build greener, which benefits everyone. Now let's shift to the business side. Competitive advantage. In an industry often seen as a commodity business competing on the lowest price, how does embracing lean actually help companies win more projects and maybe even attract scarce talent?
That's a great question because it cuts to the core business case for lean. You're right, construction is incredibly competitive, often driven by razor-thin margins and that relentless pressure to submit the lowest bid. But lean offers companies a way to differentiate themselves powerfully based on value rather than just price alone.
How so? How does it make their bids more competitive if they might not always be the absolute cheapest up front?
Because sophisticated clients are increasingly looking beyond just the initial bid price. They've been burned by low bids that balloon later due to delays, changes, and poor quality. Lean companies can offer something more valuable, greater reliability and predictability. They can demonstrate a track record of delivering projects on time, on budget, with higher quality, and fewer disruptive surprises or change orders during construction. These factors, risk reduction, predictability, reliability, are increasingly valued by clients, sometimes even more than the lowest initial number. They're willing to pay a small premium for peace of mind.
And reputation must snowball here. Once a client has a good experience with a reliable lean contractor.
Absolutely. Documented successes on lean projects build an incredibly strong reputation and generate powerful word-of-mouth referrals. It creates a virtuous cycle. We saw survey data from Italy, for instance, showing 85% of clients now consider efficiency and predictability as top selection factors when choosing a contractor, often ranking them as high as or higher than the initial price. This fundamentally shifts the competitive dynamic away from just a race to the bottom.
Is there data to back up this competitive advantage? Do lean firms actually win more?
Yes, the data is compelling. Studies tracking firms that have achieved lean construction certifications show, on average, things like a 67% increase in their bid success rates, a 35% increase in operating margins because they're more efficient and have less waste, and a 73% client retention rate. They're not just winning more bids, they're building stronger, longer-lasting relationships with their clients.
So what specific strategies do these contractors use to leverage their lean capabilities when they're bidding for work?
They often present a clearly differentiated value proposition. They don't just talk about price. They highlight the risk reduction, the transparency, the collaborative approach, and the overall project optimization that their lean system brings. They use detailed case studies with hard quantitative data, like the examples we've discussed, to prove their claims. Some forward-thinking firms even propose open book contracts or other collaborative contracting models where there's transparency on costs and benefits are shared, further aligning their interests with the clients. And conducting early collaborative workshops with potential clients during the bidding phase can be very effective in demonstrating their lean approach and building trust from day one.
Can you give us a concrete example of a company that really changed its market game using lean?
Sure, there's the case of Costruzioni Modern SPA, a mid-sized Italian contractor specializing in industrial facilities. Historically, they competed primarily on lowest price, often struggling with profitability. They made a strategic decision to fully embrace lean, investing significantly in training their people and redesigning their core processes. As a result, they completely transformed their market position. They shifted from being just another low bidder to becoming a preferred partner for demanding industrial clients who valued reliability.
And the financial results.
They actually saw their average contract price increase by 5%. Clients were willing to pay a premium for their demonstrated reliability and quality. And even more impressively, their overall profitability increased by 40%, driven by the drastic reduction in waste, rework, and inefficiencies achieved through lean. It was a complete strategic turnaround, moving from commodity to value provider.
That's a massive impact on the bottom line and market perception. What about the talent side? Construction faces huge labor shortages. Does lean help attract good people?
It's a significant, often underestimated advantage. Companies that genuinely embrace lean, with its focus on collaboration, continuous improvement, respect for people, and innovation, create a much more engaging and empowering work environment. This makes them far more attractive to skilled professionals, especially younger generations entering the workforce, who are often looking for more than just a paycheck. They want to work for forward-thinking companies that value their input and operate efficiently. In a tight labor market, being a lean company can be a major differentiator in attracting and retaining top talent.
That makes perfect sense. Now, this improved predictability and reliability must also resonate strongly with investors and financiers, right? Construction projects are notoriously risky investments.
This is a huge point and a major benefit of lean that's gaining more recognition. For investors, developers, and lenders, construction has traditionally been a high-risk proposition. The statistics are grim. As we noted, something like 70% of large projects exceed their initial budgets, often by 30% or more, and 85% miss their deadlines, with average delays around 40%. This massive uncertainty makes financing projects more difficult, more expensive, and frankly scares away a lot of potential capital investment.
So how does lean change that perception for the financial community?
Lean directly addresses the root causes of that uncertainty. By focusing relentlessly on reducing process variability, improving workflow reliability through tools like LPS, enhancing communication, and proactively managing risks, lean makes project outcomes significantly more predictable. For investors and financiers, predictability equals lower risk.
What are the tangible financial benefits for them when a project adopts lean principles?
There are several key benefits. First, reduced financial risk. When lenders perceive lower risk of delays and overruns, they are often willing to offer more favorable interest rates and financing terms. Lean projects are simply seen as safer investments. Second, accelerated return on investment, ROI. Faster project completion times, which lean consistently delivers, mean the asset, be it an office building, an apartment complex, or a factory, starts generating revenue sooner. This significantly improves the project's net present value, NPV, and overall investment returns. Time really is money for investors, and lean saves time.
Getting that return flowing sooner is a massive driver. What else?
Third, optimized cash flow. The reliable planning inherent in lean allows for much more accurate cash flow forecasting and management throughout the project lifecycle. Capital can be deployed more efficiently without large contingencies tied up for unforeseen problems. And fourth, enhanced asset value. Projects completed on time, on budget, and built to a high standard of quality generally achieve better market valuations and command higher rents or sale prices upon completion. It de-risks the entire investment from start to finish.
Do we have an example of an investor specifically choosing lean partners and seeing these results?
Yes, the source material mentions the Urban Renaissance Real Estate Fund. After getting burned by significant cost overruns and delays on some of their earlier traditional projects, they made a strategic shift. They began specifically selecting construction partners based on their demonstrated lean capabilities and even started incorporating lean performance clauses into their contracts.
A proactive approach. And what was the outcome of that strategy?
The results were quite dramatic. Across 12 subsequent projects managed using lean principles, their average budget deviation plummeted from 23% on previous projects down to just 7%. And average schedule delays were slashed from 35% down to within 10%. This increased predictability and reduced risk profile directly boosted the fund's overall investment return by 2.4 percentage points. That's a significant improvement, proving that lean isn't just an operational strategy for contractors, it's a powerful financial tool for investors and developers too.
That's clear, quantifiable proof. Okay, finally, we have a really interesting case study that takes lean beyond the physical construction site itself into the realm of operational management. Bologna International Airport in 2018. This seems to stretch the definition of construction a bit.
It does, but it's a fantastic example because it perfectly illustrates the universality and adaptability of lean principles. Lean isn't just about building things, it's about optimizing any process or system where value is created and waste exists. In 2018, Bologna Airport faced a common challenge for many mid-sized airports.
What was the specific challenge?
They were dealing with sharp, seasonal peaks in passenger traffic that strained their existing infrastructure. They had structural limitations in the terminal building that created bottlenecks. They needed to improve the overall passenger experience to remain competitive. They had stringent security standards to maintain. And they were facing increasing competition from other regional airports. The typical response might have been, "We need a massive, expensive terminal expansion."
But they took a different approach first, a lean approach.
Exactly. Instead of jumping straight to costly capital expenditure, they launched an ambitious project called Flow, focused on optimizing their existing operational processes for passengers and baggage using lean principles. It involved bringing together all the stakeholders, airport management, airline staff, ground handling companies, security personnel, even passenger representatives, to look at the entire end-to-end journey through the airport as a single value stream.
Seeing the airport as a system, what were the key phases of applying lean in this operational context?
They followed a structured lean approach. Phase 1 was flow mapping. The team meticulously mapped every step of the passenger journey: check-in, bag drop, security, immigration, boarding, and the parallel baggage handling process. They identified bottlenecks, queues, redundant steps, excessive walking distances, and points of frustration. They used techniques like passenger shadowing, literally following passengers discreetly to see the real experience alongside data analysis from airport systems and sensors to build a detailed current state map of the flows and identify the biggest pain points.
Really understanding the current reality from the customer's perspective. What came next?
Phase 2 was process redesign. Based on that detailed analysis, the cross-functional teams redesigned key airport processes. They focused on creating more linear, intuitive flows, eliminating unnecessary waiting and walking, improving signage, and streamlining handoffs between different entities, like airlines and security, all while maintaining or even enhancing security effectiveness.
Did they just flip a switch or test things out?
They were smart about it. Phase 3 was pilot implementation. Proposed solutions were tested incrementally in controlled pilot areas, maybe one bank of check-in counters or a single security lane before being rolled out airport-wide. This allowed them to gather real data, refine the solutions based on feedback from staff and passengers, demonstrate concrete benefits, and crucially, help overcome the natural resistance to changing established routines.
Building buy-in through proven success, and finally, making it stick.
Phase 4 was standardization and continuous improvement. Once a solution was proven effective in the pilot, the new procedures were standardized, documented, and staff were trained. Key performance indicators, KPIs, related to flow and waiting times were established and monitored continuously. Feedback mechanisms from both passengers and staff were put in place to ensure the improvements were sustained and to fuel an ongoing cycle of Kaizen continuous refinement and further optimization. It wasn't a one-off project. It became embedded in their operational culture.
Were there any particularly clever innovations or technologies that came out of this flow project at Bologna?
Yes. Several really smart applications stood out. They implemented dynamic queue management systems, particularly at security checkpoints. These used predictive algorithms, analyzing flight schedules, booking data, and historical trends to anticipate passenger arrival peaks and adjust staffing levels and open lanes proactively in real time, smoothing out the queues. They redesigned the security layout into a more efficient one-stop process, where possible, reducing passenger backtracking and confusion. They invested heavily in clear, intuitive, dynamic visual management through better signage and real-time information displays. And they utilized anonymous passenger flow monitoring technology, using Wi-Fi and Bluetooth signals from passengers' devices to track congestion levels in different parts of the terminal in real time, allowing operational managers to identify emerging bottlenecks and deploy staff proactively to resolve them.
Those sound like really intelligent applications of lean flow principles combined with technology. What were the tangible results for the airport and its passengers?
The results were genuinely impressive. They achieved a 40% reduction in average passenger waiting times at security during peak hours. They managed to increase their overall passenger processing capacity by 25% without any major structural expansion, a huge efficiency gain using existing assets. They saw a 15% improvement in on-time flight departures because the boarding process became smoother and more predictable. And maybe most importantly, they recorded an 18% increase in overall passenger satisfaction scores based on surveys.
That's fantastic. Doing more with less, improving the experience, saving money. It really drives home that lean thinking can optimize complex operations and service flows, not just physical construction. It's about managing flow, whether that flow is concrete, materials, information, or people.
Exactly. It's a powerful testament to the versatility and adaptability of the core lean principles.
Okay, so we've seen the power of lean in action. Looking ahead, how do we really build a sustainable lean future for the entire construction industry? What about things like global standards, certifications? Is there an organized body leading this charge?
Yes, there is. A crucial part of embedding lean long-term involves formalizing knowledge, sharing best practices, and building a community. The Lean Construction Institute, or LCI, founded back in 1997 by those pioneers Glenn Ballard and Greg Howell, is really the global anchor point and authority for lean in the construction world. They now have active chapters in over 20 countries, including LCI Italia. It's more than just an institute, it's really a global movement driving transformation.
What is LCI's core mission and how are they driving this transformation?
Their mission is fundamentally about transforming the architecture, engineering, and construction AEC industry through research, education, and the widespread dissemination of lean principles and practices that create value for everyone involved in a project. They've played a vital role in codifying key methodologies and getting the word out. For instance, they formally defined and trademarked the last planner system, they adapted target value design specifically for the construction context, and they've been instrumental in developing and promoting integrated project delivery IPD models.
IPD, what's that?
IPD models are essentially collaborative contractual frameworks. They're designed to align the financial interests and goals of the entire project. Team owner, designer, contractor, key subs, right from the beginning. They encourage shared risk and reward, fostering the trust and collaboration that is absolutely essential for deep lean implementation.
That sounds like a crucial piece, changing the contracts to support collaboration. Does LCI also offer certifications for individuals to demonstrate their lean competence?
Yes, they do. They have a structured certification program to recognize individual knowledge and expertise. There's the Lean Construction Certified Practitioner, LCCP, which covers foundational knowledge and application. Then the Lean Construction Certified Expert, LCCE, for those leading more advanced implementations and driving change within organizations. And the highest level is the Lean Construction Certified Coach, LCCC, aimed at experienced professionals who train others or lead large-scale lean transformations.
So individuals can get certified. What about organizations? Can they measure their lean maturity?
Yes. LCI has developed the Lean Construction Maturity Model, LCMM. This allows companies to assess how far along they are on their lean journey across 5 key dimensions: leadership commitment, process optimization, collaborative relationships, customer focus, and business results. It provides a roadmap for organizational development.
And knowledge sharing is a big part of what they do, too.
Absolutely. LCI facilitates knowledge dissemination through annual conferences, publishing research and case studies, hosting webinars, and supporting local communities of practice where professionals can meet regularly to share experiences, discuss challenges, and learn from each other. Building this robust ecosystem of shared learning is critical for sustaining momentum in such a large and fragmented industry.
That focus on learning leads perfectly into the next crucial element: developing lean competencies within organizations. It sounds like investing in people training and skill development is maybe the single most critical factor for making this transformation stick. So more about learning tools or changing mindsets. It's definitely both. But you're right, the mindset shift is probably the most critical and often the hardest part. Effective, sustainable lean implementation requires a significant ongoing investment in training and skill development for everyone in the organization, from the executive suite right down to the frontline workers on the tools. It's not just about teaching them how to use a specific tool like VSM. It's about cultivating a completely new way of thinking about work, identifying waste, collaborating, and solving problems continuously. It's about empowering everyone to be an agent of improvement.
What are the key principles for making that training effective in a construction context? People learn differently than in an office. That's a great point. Training needs to be tailored. Key principles include making it highly practical and visual. Construction workers often learn best by doing, so prioritize hands-on learning, simulations, site-based exercises, and demonstrations over purely theoretical lectures. Training must be contextualized, using real-world construction examples, case studies, and terminology that resonates with their daily experience. It needs to be gradual, starting with foundational concepts like the 8 wastes and 5S, then progressing incrementally to more advanced tools like LPS or TAC planning as competence builds. And crucially, training should be collective. Train entire teams or work crews together, not just individuals in isolation. This fosters shared understanding, common language, and reinforces the collaborative aspect of lean. You can't have just one person trying to be lean on a team.
What specific competency areas should these training programs focus on building?
It's a mix. Obviously, understanding the technical lean tools themselves, how to conduct a 5S event, how to participate in LPS planning, how to read a VSM map. But just as important are analysis and improvement skills, how to identify root causes of problems, how to measure performance, how to brainstorm and test solutions. Also critical are collaborative skills, effective communication, active listening, constructive conflict resolution, teamwork. And for managers and supervisors, specific training in lean leadership is vital. How to coach teams, empower them to solve problems, foster a culture of continuous improvement, and lead by example.
Are there innovative ways companies are delivering this training beyond the traditional classroom?
Yes, many are moving beyond that. On-the-job coaching by experienced internal or external lean coaches who work alongside teams on real projects is incredibly effective. Some companies create simulated training construction sites or use serious games to allow teams to practice lean principles and tools in a safe, controlled environment before applying them on a live project. Developing internal certification programs can motivate learning and recognize competence. And increasingly, adaptive digital learning platforms, accessible via mobile devices, are being used to deliver bite-sized, just-in-time training content directly to workers in the field. The key, whatever the method, is to measure the impact not just on knowledge acquired, but on actual observable behavioral changes on-site and demonstrable improvements in operational results. Does the training actually change how people work?
Right, ensuring the training translates into real action. Now, this next topic sounds like the future arriving. Lean and Industry 4.0. Convergence of lean philosophy with advanced digital technologies. This sounds potentially game-changing for construction.
It absolutely is. This integration, combining the waste elimination focus and process optimization mindset of lean with the power of Industry 4.0 technologies like the Internet of Things, IoT, big data analytics, artificial intelligence, AI, robotics, augmented reality, AR, digital twins, 3D printing, even blockchain is poised to fundamentally revolutionize how we design, build, and manage assets in the built environment. The key is that lean principles guide the application of the technology. We're not just adopting shiny new tech for its own sake. We're using it strategically to eliminate specific waste and create tangible value.
What are some of the key synergies? How do lean and these advanced technologies reinforce each other?
The synergies are immense and multifaceted. For example, digitalization itself, moving from paper-based processes to digital workflows, inherently eliminates information waste, creates better data transparency, and enables faster communication, all core lean goals. Connectivity through IoT sensors on equipment, materials, even workers, allows for real-time monitoring of location, status, and performance. This provides unprecedented transparency for things like JIT material tracking or predictive maintenance, enabling timely interventions. Automation and robotics can take over dangerous, dirty, or highly repetitive tasks like bricklaying, welding, or drone-based site surveys, improving safety, precision, and consistency while freeing up human workers for higher value, more complex problem-solving activities aligning with the respect for people principle. And advanced analytics and AI can crunch the vast amounts of data generated by projects to identify hidden patterns, predict potential problems like delays or cost overruns before they happen, and even suggest optimized solutions, essentially supercharging the Kaizen cycle of continuous improvement.
So lean provides the why and the what to improve, and Industry 4.0 provides powerful new hows to do it. What are the hurdles? It sounds great, but integrating all this must be challenging.
It definitely comes with challenges. One major issue is digital fragmentation. If different systems don't talk to each other, you can actually create new information silos, which directly contradicts Lean's principle of flow. There's also the digital divide in skills. The construction workforce needs significant upskilling and reskilling to effectively use these new tools. There's a real risk of technological overload, adopting too much tech too quickly without a clear strategic purpose or demonstrated value proposition, leading to confusion and wasted investment. And of course, data privacy and cybersecurity become increasingly critical concerns as more project information becomes digitized and connected.
Are we seeing pioneering companies already successfully navigating these challenges and integrating Lean with Industry 4.0?
Yes, absolutely. We're seeing pioneers emerge. For instance, the source mentions NCC in Sweden, a major contractor. They've developed what they call digital lean construction, which combines the collaborative planning of LPS with real-time site monitoring using IoT sensors and advanced analytics. Their system can actually analyze progress data and suggest optimized adjustments to the work sequence in near real time directly to crews via tablets. Another example is Impresa Percassi in Italy. They've implemented smart prefabrication, leveraging parametric design tools, robotic fabrication, and even 3D printing for complex custom components, allowing them to drastically reduce material waste, ensure precise quality, and significantly speed up on-site assembly.
So it's happening. What does the industry need to do to make this powerful convergence more widespread?
Several things are needed. Firstly, integrated training programs that teach both lean methodologies and relevant digital skills together. Secondly, much greater cross-sector collaboration between construction firms, technology providers, software developers, and research institutions to develop integrated, interoperable solutions tailored to construction's needs. Thirdly, the development and adoption of open standards for data exchange, like IFC for BIM, are crucial to overcome that digital fragmentation issue. And finally, maintaining that relentless focus on value from lean thinking is paramount, ensuring that technology adoption is always driven by a clear purpose to eliminate waste, improve flow, enhance safety, or deliver better value to the customer, not just because the tech is cool.
That's a clear pathway for leveraging technology smartly. Okay, let's bring it back to the implementation journey itself. For a company inspired by all this, wanting to adopt Lean, what's the roadmap? You emphasized it needs to be strategic and gradual, not a big bang approach.
Exactly. Trying to change everything overnight in a traditional construction company is almost guaranteed to fail due to resistance and complexity. A structured, phased approach is much more effective for building capability, demonstrating value, and achieving sustainable transformation.
So what's phase one? Where does a company even begin?
Phase one is all about awareness and initial assessment. It starts with educating senior leadership, conducting workshops to ensure they understand the core principles, the potential benefits, and the commitment required. Then, conduct an honest assessment of the company's current state using something like the Lean Construction Maturity Model, LCMM. Identify the biggest pain points, where are the most significant sources of waste, delays, and frustration. Based on this, define a clear, shared vision for what lean transformation means for this company and set some initial measurable goals. It's about building alignment and understanding where you are before you start running.
Okay, leadership buy-in and assessment first. Then phase two must be about trying it out, getting some early wins.
Precisely. Phase two is pilot projects and quick wins. Don't try to boil the ocean. Select one or maybe two specific manageable projects or work areas to serve as a lean laboratory. Implement some foundational, highly visible lean tools first, maybe 5S for workplace organization, basic visual management boards for tracking progress. Introduce daily coordination meetings or huddles for the teams involved. Provide practical, hands-on training focused on those specific tools, and critically, rigorously measure the results of the pilot track KPIs like PPC, lead time, waste reduction, safety improvements. Demonstrating tangible success, even on a small scale, is vital for building momentum, generating enthusiasm, and overcoming skepticism elsewhere in the organization.
Build credibility through results. Then, phase three, scaling up.
Yes. Phase three is expansion and deepening. Once you've proven the concept and learned from the pilots, start extending the basic tools, 5S, visual management, daily huddles, to more projects and teams. Introduce more complex methodologies systematically, like the last planner system or value stream mapping for key processes. Train internal lean champions or coaches who can support teams, facilitate workshops, and act as multipliers for the transformation. Begin developing organization-specific lean standards and procedures based on what you've learned works in your context. And importantly, start actively involving key subcontractors and suppliers in your lean initiatives, extending the thinking beyond your own four walls.
And the ultimate goal, Phase 4, embedding it into the culture.
Phase 4 is cultural and systemic transformation. This is where lean stops being a special project and becomes simply the way we do things here. It involves aligning organizational systems like performance management, incentives, and recognition with lean principles, integrating lean thinking deeply into the company's overall business strategy, planning processes, and risk management, implementing a structured, self-sustaining continuous improvement system, like a formal Kaizen program, and fostering truly long-term collaborative relationships with clients, designers, and suppliers based on trust and shared value creation. This phase is about making the changes permanent and part of the organizational DNA.
Throughout this whole journey, change management must be absolutely critical. People naturally resist change, especially in a traditional industry.
It's arguably the most critical success factor. You can have the best tools and processes in the world, but if you don't manage the human side of change effectively, the transformation will likely fail. Key elements include clear, consistent, and two-way communication explaining the why behind the changes, listening to concerns, celebrating successes, active involvement and engagement at all levels. People support what they help create. Providing ongoing on-field support, coaching, and encouragement is essential to help people navigate the challenges, build new habits, and overcome resistance until the new ways of working become second nature. Leadership visibility and unwavering commitment are paramount.
Okay, so if you're going through this journey, you need to measure success. What are the right key performance indicators, KPIs, for lean construction to ensure you're actually improving and heading in the right direction?
That old adage, what doesn't get measured doesn't get improved, is absolutely central to lean. You need good KPIs. Effective KPIs should be SMART specific, measurable, achievable, relevant, and time-bound. But more broadly, they need to be easily understandable by the teams using them, balanced across different aspects of performance, not just cost, and directly actionable. They should guide improvement efforts.
Can you give us examples across different categories, maybe starting with process KPIs, since lean is so focused on flow and reliability?
Sure. Key process KPIs include percent plan complete, PPC from the last planner system, measuring planning reliability, lead time for key processes, e.g. design approval cycle time, material procurement lead time, time to complete a typical floor cycle, takt time adherence, how consistently are we hitting the plan rhythm, constraint removal rate, how effectively are we identifying and removing roadblocks before they impact work. These tell you if your processes are getting healthier.
Okay, what about the bottom line? Economic KPIs.
Here you'd track things like cost predictability, final cost versus budget variance, the value added ratio, percentage of time spent on actual value creating work versus total time, inventory turnover for materials, and crucially, the cost of poor quality or rework, cost directly measuring the financial impact of defects and inefficiencies.
And measuring the human element, involvement KPIs. How do you track culture change?
These are really important for gauging engagement. You can measure the improvement suggestions rate, for example, number of implemented Kaizen ideas per employee per year, the implementation rate of those suggestions, training hours per employee focused on lean skills, participation rates in daily huddles or problem-solving workshops. These indicate whether people are actively engaged in the improvement process.
And finally, quality and safety KPIs, beyond just the end results.
For quality, first-time quality, FTQ, is key. The percentage of work completed correctly the first time without needing any rework. For safety, tracking proactive indicators like the number of safety observations or hazard reports submitted, and the near-miss rate often provides better leading indicators of safety performance than just lagging indicators like injury rates. And of course, customer satisfaction scores remain a vital ultimate measure of quality and value delivery.
It sounds like the key is to use a balanced scorecard of KPIs with a strong emphasis on those process metrics that predict future results.
Exactly. Lean strongly emphasizes monitoring process KPIs because they give you early warnings and insights into why things might be going off track, allowing for proactive interventions rather than just reacting after a problem has occurred and impacted the outcome KPIs, like cost or schedule. And as a company's lean implementation matures, the KPIs themselves should evolve to measure overall system maturity, and they can be carefully linked to team-based recognition or incentives, though this needs careful design, to further reinforce desired behaviors and drive continuous improvement.
So wrapping this all up, what we've explored today really shows that lean construction is, well, it's far more than just a new set of tools or jargon. It feels like a fundamental paradigm shift for the entire construction industry.
It really is. It directly tackles some of the most deep-seated, persistent challenges that have plagued construction for decades. from chronic low productivity and predictability issues to its significant environmental footprint, worker safety concerns, and often adversarial stakeholder relationships. It offers a pathway to turn what's often a chaotic, unpredictable process into something much more controlled, efficient, and value-driven.
And the case studies, we looked at the incredible precision of that Milan roadwork, the stunning success of the historic Palazzo Contarini restoration in Venice despite immense complexity, the integrated efficiency and safety achieved at the Genoa port, and even the optimized passenger flow at Bologna Airport. They all powerfully underscore the undeniable, measurable benefits across incredibly diverse project types.
Absolutely. We're consistently seeing significant reductions in project time and cost, tangible improvements in construction quality and site safety, a demonstrably lighter environmental footprint, and ultimately more satisfied clients, communities, and investors. The evidence is compelling.
Now, we also acknowledge the real hurdles, the cultural inertia, the organizational resistance, the need for new skills. The journey isn't necessarily easy or a quick fix.
No, it requires commitment and persistence.
But the strategies we discussed for implementation, that gradual, phased approach, starting with pilots, focusing on training and coaching, ensuring strong leadership commitment, adapting tools like LPS to the specific context they demonstrate that these challenges absolutely can be overcome.
And ultimately, building a truly lean future for construction requires more than just individual companies changing. It really demands an evolution of the entire industry ecosystem. That means adopting more collaborative contract models like IPD that align everyone's interests. It means integrating lean thinking into university curricula for architects, engineers, and construction managers
Even
day one.
It might even involve public policies that actively incentivize efficiency, waste reduction, and sustainability in public projects.
And that convergence with Industry 4.0 technologies we touched on, if guided by lean principles of value and waste elimination, that holds just immense potential to finally move construction beyond its traditional, often artisanal limitations into a truly optimized, data-driven, and much smarter future.
The potential is huge. So what's the final provocative thought for you, our listener, to take away from this deep dive? Well, it means that the next time you see a major building project rising or navigate around complex roadworks, pause for a moment. You might just be witnessing a quiet revolution in progress, a testament to how a philosophy born from scarcity in post-war Japan, the relentless pursuit of eliminating waste and maximizing value, can drive unparalleled efficiency and create a more predictable, significantly safer, and demonstrably greener future for the world we build around us. It's really about building not just faster or cheaper, but fundamentally smarter, and that surely is a foundation we can all build upon.